In the freezing depths of the Norwegian Sea, 1,680 meters down, a massive machine rests in the dark. This is the Soviet K-278 Komsomolets. Today, it remains an active radiation source, leaking isotopes directly into the surrounding water. Trapped inside its crushed hull is a deteriorating nuclear reactor, along with 2 torpedoes armed with nuclear warheads. To understand why this radioactive hazard is sitting on the ocean floor, we have to look at the extreme engineering that put it there in the first place. In the 1960s and 70s, the Soviet Navy faced a highly specific problem: the American Mark 48 torpedo. This weapon could hunt and destroy submarines at depths down to 800 meters. The Soviet response was Project 685, a mandate to build a submarine capable of diving past 1,000 meters, placing it completely out of reach of Western weapons. Hitting that 1,000-meter mark meant abandoning conventional steel. Instead, designers constructed the inner pressure hull out of titanium, an incredibly expensive metal, notoriously difficult to weld and machine on a massive scale. Titanium gave them the depth they needed, but it required strict compromises. To save weight and space inside that specialized hull, engineers relied heavily on automated systems, shrinking the crew down to roughly half the size of a standard attack sub. The designers also knew that diving a mile deep carried immense risk. To compensate, they embedded a detachable escape capsule directly into the submarine's sail, designed to carry the entire crew to the surface in an emergency. The Komsomolets was an apex predator pushed to the absolute limits of physics. But that hyper-specialized design set the stage for a disaster where its greatest strengths would become fatal liabilities. On April 7, 1989, the Komsomolets was cruising at a routine depth of 386 meters when a short circuit ignites hydraulic fluid in the aft steering section, known as Compartment 7. For a frontline nuclear submarine, an isolated electrical fire like this is a standard emergency that crews drill for constantly. The captain made the textbook decision: blow the main ballast tanks to rapidly bring the boat to the safety of the surface. But the high-pressure air lines needed to empty those ballast tanks ran directly through the burning compartment. The extreme heat melted the piping. When ruptured, they acted like a giant bellows, injecting massive compressed oxygen and turning Compartment 7 into an 800-degree blast furnace. The exact mechanism designed to save the ship was actively feeding the inferno. The heat grew so intense it melted the plastic seals in the ventilation system. This allowed thick, toxic carbon monoxide to bypass the sealed bulkheads and pour into the forward sections of the ship. Building a sub to run automatically with a skeletal crew meant there were simply no specialized hands available to form a dedicated damage control party when the automation failed. The toxic gas quickly overpowered the few sailors who were trying to fight the blaze, rendering manual firefighting impossible. The final blow was a matter of basic physics. As the submarine surfaced and the fire consumed the remaining oxygen in the aft compartments, the internal air pressure plummeted. This massive pressure drop sucked seawater backward into the ship, through hull seals that had been warped by the heat. After a grueling 5-hour struggle, the flooded titanium Leviathan lost its buoyancy, pitching its bow toward the sky before sliding beneath the waves. As the submarine sank, 6 men, including the captain, deployed the final failsafe. They sealed themselves inside that high-tech titanium escape capsule in the sail, but the capsule's complex release mechanism jammed. Instead of floating free, the pod remained firmly attached to the hull, dragging the men down toward crush depth. The pod only broke loose from its mounts when the massive weight of the submarine violently slammed into the seabed, over a mile below the surface. Suddenly buoyant, the capsule shot to the surface in a rapid, uncontrolled ascent. The violent change in pressure caused a lethal explosive decompression that blew the top hatch completely off, drowning the remaining men inside. The specific technology designed to be their deep-water sanctuary failed at every step, trapping them inside. In total, 42 of the 69 crew members died. Most actually escaped the burning submarine, only to freeze to death in the frigid 2-degree water while waiting for delayed rescue ships. The Komsomolets is a textbook system accident. A series of highly complex, interconnected subsystems interacted in ways the designers never foresaw, creating a chain reaction that destroyed the ship. Today, deep-sea surveys conducted by Norwegian ROVs show that the reactor's fuel assemblies are actively corroding. The wreck is releasing measured pulses of radioactive cesium-137 directly into the surrounding water. The extreme dilution of the deep ocean prevents an immediate localized ecological collapse, but the leak is continuous, requiring constant international monitoring to ensure the safety of the region. Measured. The K-278 Komsomolets remains a silent, radioactive monument on the seafloor. It proves that extreme technological ambition, built without respect for the limits of human control, will eventually engineer its own destruction.